ARYABHATTA, one of the greatest Indian mathematicians and astronomers. In fact, the first Indian satellite launched back in 1975 was named after ARYABHATTA. Mostly what we know about this great genius is that he invented zero, and that's about it. And not much that we hear about ARYABHATTA in the mainstream Indian education. Well, is it just the zero that he has invented? No, not at all. There is a lot more to it. And this short documentary is our small attempt to bring forward all the discoveries of ARYABHATTA beyond zero. In the next couple of minutes, let us understand about ARYABHATTA, his life and works, his key contributions, and how his influence has been in India and across the world in the field of mathematics and astronomy. Starting with ARYABHATTA's life and his works. Back in the 5th century, during the reign of Gupta's dynasty, one of the golden ages of India in the earlier millennia, ARYABHATTA was born in and around Pataliputra or modern-day Patna in Bihar on March 21st, year 476 CE. He was one of the greatest mathematicians and astronomers of those times, and very little is known about his personal life. All that we know about ARYABHATTA is through his works, where he documented a lot of mathematical and astronomical details in a couple of scriptures. The most important works of ARYABHATTA is in the name of ARYABHATTIYA. It's a treatise on astronomy, astrophysics and mathematics. And the second one is ARYASIDDHANTA, which further talks about all the mathematical concepts involved in astronomical calculations. ARYASIDDHANTA is now lost, and few traces of ARYASIDDHANTA are referred in the subsequent mathematicians and astronomers of 7th and 8th centuries onwards. We don't know what exactly was described in ARYASIDDHANTA beyond very few details that were quoted by other astronomers in their scriptures. And the third one is Al-Nanf. This also is a lost scripture of ARYABHATTA, and this one is quoted from the West Asians or the Persians as part of their mathematical scriptures. Of all, ARYABHATTIYA is the only text that is well preserved completely as it is written by ARYABHATTA 1500 years ago. Astronomy has been a very important field of science that has contributed to the development of mathematics back in ancient India. And talking of astronomy, Suryasiddhanta, a scripture given by Lord Surya himself towards the humanity. This scripture is the world's oldest treatise available on astronomy till date. No historical dating has been ascribed to Suryasiddhanta yet and is considered as prehistoric. And this Suryasiddhanta has been the baseline for ARYABHATTA's work in ARYABHATTIYA. India has a very powerful linguistic tradition with Sanskritam, a language that is capable of condensing huge amounts of information in very short format, and ARYABHATTA stands as yet another example for that. The entire ARYABHATTIYA is just 121 slokas. It means you can just print them in 2 or 3 papers, and that's about it, but it holds a wealth of information. Here is what it looks like. ARYABHATTIYA internally is divided into 4 chapters. They are Geetikapada, Ganitapada, Kalakriyapada, and Gorlapada. Let us see what they are in detail. The first chapter is Geetikapada. The very fundamentals of mathematics are described in this chapter, starting from how to write numbers. And most importantly, this chapter focuses on the units of measurement of time. It explains in great detail about how time computation was classified back in ancient India, which of course is still in tradition till today. Then calculations of Earth's rotations and rest all mathematical concepts in and around time computation. Basically, these are the fundamentals, not the specifics yet. And the second chapter is Ganitapada, and in this chapter ARYABHATTA talks about the geometrical principles like measurement of area of different geometrical shapes, both 2-dimensional as well as 3-dimensional. And then he talks about arithmetic progressions, which are like calculating the sum of a series or sum of squares of a series. So basically different arithmetic progressions which we have learned in our high school. And the most important of all, indeterminate equations, dealing with the unknown quantities, your algebra, the foundations of it. And one of the very important contributions from ARYABHATTA, dealing with indeterminate equations, is explained in Ganitapada and many more. Basically, this chapter, with its concepts that I just said, are the foundations for the next chapters, which deals with computing planetary positions, their orbits, their sizes, and their movements. Up next is the third chapter, Kalakriyapada, as the name suggests. This chapter deals with measurement of time. How do we put to practice what was explained in chapters 1 and 2? From measurement of time determining the planetary positions, determining days of week, and many more. While reading this chapter, one thing was very clear that I could understand. He talks about the velocities of planets to be different in different places in their orbits. In fact, like I mentioned in one of my earlier documentaries on Vedic geometry, Aryabhatta is the first one to discover the equation of speed is equal to distance by time, which is one of the foundational pillars of physics as we know today. But not many people are aware of his contributions, unfortunately. Anyways, let's move on. The last one and the fourth chapter is ARYABHATTA, and as the name suggests, it deals with Bhugorla or the Earth. This chapter contains the trigonometric principles, motions of planets, observing from Earth, and the geospatial computations of time, location, and a lot more. One very important thing to understand here is trigonometry has its roots in astronomy. As you might know, trigonometry is about calculating the ratios of the sides of a triangle as a function of its angles. The reason why this entire science of trigonometry originated is to compute the angles of observation of planets standing on Earth. And speaking of trigonometry, we always hear about the contributions that came in from Greeks, but there are much older and certain incredible contributions to trigonometry that came in from India, and we'll briefly go through them as well in this video. And that's briefly what we saw is about the life and works of Aryabhatta. And speaking of his contributions, now let's quickly see certain key contributions that came in from Aryabhatta. And I would like to make one point very clear here. Aryabhatta is a very complex mathematical and astronomical treatise. So I just handpicked very few contributions which are easy to understand for everybody, all age groups who are watching this video. And in this video, I'm not going to cover the contributions if they are a little more complex. For instance, dealing with indeterminate equations, I did not cover in this video for a simple reason. Not everyone will be able to understand it, and our intention here in this video is to make a simple and lucid documentary about Aryabhatta. So if you're a physics or a maths geek, instead of watching this video, I suggest you pick up his book ARYABHATTA and start reading it. It's pretty easily available online. So now let's see what are the key contributions that came in from Aryabhatta. Starting with the first one, writing numbers as alphabets. Let me take a pause here. I read comments from a couple of people on my documentary about gravity. If I have to summarize, people were of impression that there were no mathematical formulas that were contributed from India on these concepts, and most of them were left theoretical in nature. But that is fundamentally wrong, and I repeat, it is fundamentally wrong, that statement, and here is why. Based on our current knowledge system, when you talk about formulas or any empirical representations, it is always done with numbers or arithmetic symbols or equations and stuff like that. But back then in ancient India, all the mathematical concepts or the formulas are written in the format of Sanskritam shlokas. And this just one contribution of Aryabhatta will clear out the misunderstandings what people are having, that Indian sciences are more theoretical in nature. No, that's not. And let us see what this contribution is about. Aryabhatta invented a system of assigning numbers to alphabets, kind of an encryption you can say, or a hashing, where you can transpose the numbers into letters or words and sentences. So basically, instead of writing sequence of numbers or large numbers, astronomical figures, which maybe runs up to 20 or 30 digits, can just be written in 2 or 3 words. That is the beauty of the system. Even till today, especially in the state of Kerala, there is a system called as Kattapayadi, where the numbers are represented in the format of Malayalam words. So basically it looks like Malayalam, but actually they are numbers. It is called as Kattapayadi system. And this system invented by Aryabhatta is the ancestor for the current Kattapayadi system in Kerala. Let us understand how this system of Aryabhatta's encryption technique works. For ease of understanding, I'll keep it very simple. So basically what he did is, he assigned all the vowels with a base 10. That means A is 10, A is 100, E is 1000, E is 10,000, and so on. And when it starts from the consonants, there are certain values that are assigned by first classifying them under one family and then assigning numbers to that family, as you see in the lookup table here. And if we would like to transpose a number into alphabets and words, all we need to do is replace the numbers with those positions here given for the alphabets from the lookup table. If this is sounding a bit difficult to understand, let me make it very simple. Open up any Excel sheet and go to the rightmost column. It shows as XFD. That is the 16,384th column, the maximum limit of columns that we have in an Excel sheet, but is represented as XFD because the columns in Excel sheet is a 26 base system. So we have A to Z, and then again from A, B, AC, and so on, just like how we have in a dictionary. So this is an exact example of how ARYABHATTA system also works. It's pretty easy to understand. Let us go through this below example. Just like how XFD, even though it looks like alphabets, but actually represents a number of 16,384. Let us take a word Kuchi and see how it actually represents a number. Now Kuchi, two-lettered word, and if we further break it down, Ku is again Ka plus U is Ku, and Cha plus E is Chi. So let's start with the first one, Ka. In the above chart, if you see, Ka represents 1, and A is a vowel, and as I said, the vowels are of base 10. So A is 1, A is 10, E is 100, E is 1000, U is 10,000. So the combination of Ka plus U will be like placing Ka in the position represented by its vowel. So Ku here takes the value of K from the chart above, and U represents the 10,000 position. So that's how Ku becomes 10,000. In the same way, Chi, following the same principle of Cha plus E from the above chart, Cha or C represented here as C takes the value of 6, and E. So that's the third one. So the third position, which is 600. So Ku plus Chi, Kuchi, is 10,600. And this is how a number is represented in the format of a word. And you'll see its practical uses as we proceed in this video. And this entire technique, which I've been explaining since last 2 minutes, is just documented by ARYABHATTA in 2 lines in the sloka above. And that is why Sanskritam is the most scientific language known to mankind. And let me clear out the misconception of few people, like I mentioned, that Indian sciences are not empirical in nature. Here is an example from Madhava of Sangramagrama. He is the first one to invent a method to calculate the value of pi to infinite digits. As you know, it's a transcendental number, it never ends. While the world was struggling adding one decimal after the other, it was Madhava who has given this formula for pi back in 1200. This entire formula is just represented in 2 lines of Sanskrit sloka given above. It doesn't look like a formula, but it is. It's just that we need to improve our competency to read Sanskritam, which unfortunately 99.999% of Indians don't have today. And until we improve on that aspect, understanding the true heritage of India is just impossible. Let's get to the second contribution of ARYABHATTA. He is one of the earliest mathematicians in India who gave the value of pi accurate to 4 digits. Again, coming back to my earlier documentary on Vedic geometry, I quoted that the value of pi was not known to Indians and its origins are of Greek or arguably Egyptians. But I got a lot of messages that pi was known to Indians much before, and the value of pi was actually discovered by Indians. Honestly, I did not find any such references which says that pi is discovered in India before Greeks. So if any of you have any concrete, correct, reliable source of information, when I'm saying it, I'm referring to the original scriptures. Please help me understand, and I'm happy to correct my statements. Until then, let's go with what ARYABHATTA gave. So what ARYABHATTA gave the value of pi as is a fraction of 2 5-digit numbers. He says that 100 added 4 multiplied by 8 and added 62,000, and this is the approximate circumference of a circle whose diameter is 20,000. So basically what he means is the ratio of the circumference to the diameter, which is pi, and the value here ends up with 3.1416. Most important thing here to notice is he says that this value is approximate and not accurate. That's what the translation of the Sanskritam sloka means. So it is very clear that ARYABHATTA is aware of the concept of pi, and he very much knows that it's a transcendental number, and that is the reason he just gave it as an approximate number and not an accurate one. The third contribution is calculating the area of a circle without using pi. So ARYABHATTA says that half of the circumference when multiplied by half of the diameter, that exactly gives the area of the circle. Again here, read the word exactly. So he's sure that the product of half of circumference and half of diameter gives an exact value of circle. So he's very sure about what he's documenting, of course. And that's why he's one of the greatest mathematicians. So this I already covered in my previous documentary on Vedic geometry, so I'll not spend much time here. Why this formula came into existence and how this can be seen in conjunction with Sulbha Sutras, where you measure the circumference of a circle with a rope and then calculate the area using these kind of formulas. Up next is another contribution where he classified time in great detail. This one you cannot really call as contribution of ARYABHATTA, because this has been the classification of time in Puranas or Vedas or any Indian scriptures talks about the same classification. The topmost unit of measurement of time is called as Kalpa, that is 1 day of Brahma, revered as the primordial source of creation of the nature and cosmos. Now his day is taken as the highest unit of measurement of time. So 1 day of Brahma or the Kalpa has 14 subunits of time, which is called as Manvantara. So they are Swayambhu Manvantara, Sarvochisha Manvantara, Uttama Manvantara, Tapasa, Raivata, Chakshusha, Vaivasvata, Savarni, Daksha Savarni, Brahma Savarni, Dharma Savarni, Rudra Savarni, Deva Savarni Manvantara, and finally Indra Savarni Manvantara. So 14 Manvantaras make 1 day of Brahma. And currently, as per ARYABHATTA, we are in Vaivasvata Manvantara highlighted here. And further down, each Manvantara has 72 subunits of time called as Yugas. So basically there are only 4 Yugas, Kruta, Treta, Dwapara and Kali Yuga, which repeats itself for 18 times. So 72 Yugas or 4 Yugas in 18 cycles make 1 Manvantara. And each Yuga again further down has millions of years. You can see the numbers that I have given here. Currently, as we all know, we are in Kali Yuga, which is the 4th leg of this Yuga cycle. Well, this sounds something like mythology, etc., but this is actually the way time is computed in India since the beginning of time. And if you go to any temple, the priest in the temple before starting any kind of a puja will narrate the entire sequence of the time where we are and then start the puja. So it has been a practice in India since thousands of years. Defining the time and place we are in while performing the puja is called as Sankalpam, and that's where you can get to hear all the time narration of the sequence and all. Anyways, let's move on. The reason why I pulled up this classification of time is, which is actually given in ARYABHATTA. ARYABHATTA gave his date of birth in a very interesting format. He says that 3/4 of a current yuga and 60 times the 60-year cycles and 23 years passed since my birth till date. So it's a long calculation, but to keep it short, so that gives us his date of birth as 21st of March 475 CE, and the date of writing the ARYABHATTA is 21st of March 499 CE. And as per ARYABHATTA, the Kali Yuga, it started approximately in 3000 BCE, plus or minus 100 or so. So that's basically how the time was computed. The reason why we need to focus on these kind of elements is, if we look at the documented history as of now, it just talks about the Harappan and Mohenjo-daro civilizations approximately between 3000 and 1300 BC. But we have a lot of historical documents like Sri Ramayana and Mahabharata, which happened thousands of years even before that. Understanding the history of a country is very, very important, because if I don't understand the history of my country in a factual format, then someone else from outside will come and narrate the history to me, and there is a huge scope for religious or political or whatever motivations which kind of distort history in their interest. Well, Aryan invasion theory is a classic example for that. Good that now it is totally shattered. Anyways, let's move on. Another great invention of ARYABHATTA is the sine function. This is the first one to identify the R sine differences in terms of arc minutes. So it's a bit technical, but I'll keep it very short and simple. So you remember the trigonometrical equations that you have learned about the sine theta, cos theta and all, how the sine wave goes on or the sine function goes on, right, in a wave pattern. So it has certain metrics to it, which if joined gives us a sine wave. So here if you read the sloka above, it says Maki, Baki, Paki, Dhaki. Sounds a bit funny, but actually these are numbers. In the earlier part of this video, we saw how the encryption technique of ARYABHATTA was given, right? Writing the numericals in the format of alphabets. That is exactly what is incorporated here. Maki is 225, Baki is 224, and so on. So looking at these shloka, nobody from outside India has a clue about what this is, unless one understands the actual ciphering technique given by ARYABHATTA. This is again another classic example of how the scriptures are holding up hidden scientific details. And to understand that, one should have the competence of Sanskritam. And many people are asking me questions about Sanskritam. Honestly, I also don't know about it. I'm just struggling to understand bits and pieces of Sanskritam. Translations, what I cover in my videos are the translations given by the Sanskritam scholars. or the researchers, which are published in various research papers and old books and stuff like that. And talking of sine function, another interesting historical fact is the name sine is of Sanskritam origin. The sine function, which was discovered in India, was initially called with the name jya. Jya represents a bow, a curved bow, just like how the half cycle of the sine wave is bent, just like a bow. So that's where it was initially called as jya in Sanskritam. And that was eventually translated by the Persian mathematicians like Al-Khwarizmi, and they started calling it as jiba, a slightly distorted variant of jya. And this jiba, eventually when it was further translated by the European mathematicians, they called it as sinum. Sinum in Latin means a fold or a bend. And finally, when it came to English, it evolved as sine. So this is the evolution of jya, which is in Sanskritam, to sine, what we call today in English. Like this, there are 120 slokas given by Aryabhatta in Aryabhattiya, which talks about incredible scientific details about mathematics and astronomy. But how can we conclude this video without talking about zero, the one which we are all very proud of? So here it is. He gave a place value system and not really a zero, to be very clear and specific. So this is what he says: ekam cha, dasham cha, shatam cha, and so on. And finally, as you see here in the box highlighted, thanam dashagunam syat, which is the place value system with a base 10. So basically, the concept of place value system is the value of the number is decided by the position in which it sits in a given number. That means 1 is just 1, but it depends on where I position this 1, the value of 1 changes. And this is a base 10 system. And what the whole world is using today, called as the Hindu numerical system, is exactly what you're seeing on screen. And this is the reason why we regard Aryabhatta as the inventor of zero. But actually we should be calling it as the place value system. And this is one of the best contributions from India towards the field of mathematics. And you want to understand the value of this one? Take two Roman numerals and try to multiply or divide them. And then you'll understand the value of place value system. This number system has eased up the arithmetic operations drastically. This is the foundation for the arithmetics what we know today. In this context, I would like to address one very important perception of people. Let's talk about eclipses. Science and superstition. A tussle between these is often that we hear as a conversations during eclipses. First of all, let's see what Aryabhatta explains about eclipses in Aryabhattiya. He clearly says the following: moon is like water and sun is like fire. Here he is metaphorically representing moon, which is cold, with water, and sun, which is hot, with fire. Moon obstructs sun and the shadow of earth obstructs moon, causing eclipses. This is what the translation of the above slokam from Aryabhattiya says. These are the words of Aryabhatta himself. And this clearly reflects the scientific fact behind the occurrence of eclipses. Now let's talk the belief around it. Most of you know the story about how Rahu and Ketu are believed to be swallowing up sun and moon during eclipses, and the belief system and how people worship around it. Now let me take this head on. The culture and the ethos of India is fundamentally built around the values of gratitude, a deep sense of gratitude towards nature, cosmos, and everything. And this is the reason why we have a lot of manifestations and personifications of gods. So eclipse is nothing but a shadow, a time specifically. Whether auspicious or inauspicious, put that aside. When the planets, which is sun and moon as per Hindu cosmology, are having significant impact in every day, every minute of our lives, it is a deep sense of gratitude and devotion that people express. And personification of those times, the shadow paths, is revered as Rahu and Ketu, along with the 7 other planets. So during those times, it has been a tradition to follow certain guidelines. There need not to be any scientific relevance to it. Whether you eat during eclipse or you don't eat, that does not need to have any scientific relevance. It is just a token of gratitude. Now the problem is twofold. One set of people ridicule it and the other set of people observe it. And the problem with the people who ridicule it are, it's a simple common sense that when someone else is believing in something, why do you want to go head on to it? And for the other set of people who are believing in it, you believe it because you respect and you devote yourself towards that belief. Do not seek any Western validation or scientific validation in everything what we do. A deep sense of gratitude and belief doesn't need any validation from anybody. If you believe it with your heart and soul, just do it. You do not need any validation from anybody else. And at the same time, for people who do not believe in it, it is a simple common sense that I should not ridicule other person's belief. This might sound a bit off topic, but the reason I brought this up is to explain that Indians know how the mechanics of eclipse works since thousands of years. This is not a superstitious civilization. Everything here is associated with a deep sense of gratitude, devotion, and values. Period. Like this, ARYABHATTA has a lot of mathematical and astronomical concepts detailed out, and like I already mentioned, I just picked up the ones which are simple and easy for everybody to understand, but there are a lot of mathematical concepts. Just to briefly touch base on, these are all what are explained in ARYABHATTA, starting with solving indeterminate equations, and then cube roots and square roots, areas of geometrical shapes, time computations across Earth, arithmetic progressions, calculating orbits of planets, diameters of planets and its epicycles, speed, distance, time calculations, planet obliquity calculations, and finally apogee and perigee calculations. Like this, there are many mathematical procedures that were given in ARYABHATTA to calculate the planetary positions and a lot more. Let's get to the final chapter of influence of ARYABHATTA in India as well as outside India. ARYABHATTA as a mathematician and his works documented in ARYABHATTIya, Aryasiddhanta and more had a profound influence on Indian mathematicians and astronomers like Varahamihira, Brahmagupta, Bhaskaracharya. There are historical records about Chinese travelers, especially I Ching in 7th century, who studied in the Nalanda University in India, picking up the mathematical concepts and translating them into Chinese language. ARYABHATTA's works were translated in Chinese as well. Coming to the West Asian part, there is incredible influence of ARYABHATTA on many Persian mathematicians like Al-Hawazim, Al-Mashar, Al-Khwarizmi, Al-Ashmi, Al-Biruni, Al-Zizi, who took inspiration from ARYABHATTA and developed the mathematical concepts further on their own as well. In fact, ARYABHATTA was referred as Al-Aryabhar in the Persian texts, the translated versions of ARYABHATTIya. No matter which field of science you take, it is always a cumulative and collective evolution of people across the world. Since here I am talking from the perspective of ARYABHATTA, I am bringing out the fact that how ARYABHATTA's works influenced others. In the same way, there are historical records about how Greek mathematicians influenced Indians. So it's all a cultural exchange back then. It's not that one civilization invented everything and the rest just simply copied from it. It's a kind of a cultural exchange. It's a knowledge transfer that happens. Every civilization has their own inventions and discoveries, and that is the reason why the science has evolved to the state where we are currently. But unfortunately, the history about science that we read today is mostly written in a Eurocentric manner. That is because of a residual effect of the colonization. Having said that, there are incredible contributions that came in from Europe, needless to say about it. But the fact is, when you're talking about the history of science, the contributions that came in from India are really significant, yet we do not hear them anywhere in today's world, at least to the extent that it's supposed to. For a human intellect to evolve, we need both inspiration from history and curiosity from science. Both put together serves the best combination for the betterment of humanity. And as always, thanks for watching.